In this lesson, we're going to continue to look at some of the concepts to do with data collection, some of the terms that we need so that we can talk intelligently about it. So, carrying on, there's two different types of experiments. There's observational studies and there's experimental studies. So again, we're just classifying where data comes from, these two things. In observational studies, researchers look at situations that are already occurring and try to make inferences. For example, a researcher might compare two groups of people, one with members who exercise and another with members who don't exercise, to see if one group is healthier than the other. So they're just looking at the groups. In other words, they're observing, right? So this idea of just sort of seeing what's going on already out there in the world. Within observational studies, we can break it down a little further. We could have a longitudinal study. That's a type of observational study where researchers measure the same variables over a long period of time. So longitudinal, think long, longitudinal. It's over a long period of time, often years or decades. A cross-sectional study, in contrast, is a type of observational study where researchers measure the variables from a population at one specific point in time. All right, so we can have either a longitudinal study or a cross-sectional study, but those are mutually exclusive terms, right? So either it is a group that's followed, let's say, a group of people that's maybe followed over a certain amount of time, or it's just a slice, a cross-sectional. Think of it sort of like a slice across the population to just get a picture, a snapshot in time. Then we have experimental studies, right? That was going back to our original, differentiation at the top of this lesson. So we just talked about observational, so now we're going to look at experimental. Experimental studies, researchers control what's going on, as opposed to in the observational ones where they're just looking at what's happening. And they make inferences based on controls, all right? So, for example, a researcher might randomly choose two similar groups and have one group perform rigorous exercise once a day for 30 days while members of the other group continue with their normal lifestyle. Researchers would then measure the fitness of both groups at the end of a month. In this example, the group that exercises is the treatment group, while the one that does not exercise is called the control group, also called the placebo group. In an experimental study, there is greater chance of determining the cause of a particular behavior because we sort of zero in on what we're trying to measure. So they can control for other variables. Three things that need to occur to determine the cause. So we have the control. Once again, many aspects have to be controlled to ensure that the experiment gives the desired effect. Then we have randomization. And the reason why we have randomization is to ensure that groups aren't biased. We talked about that in a previous lesson. If things aren't random, then we can't be sure that everybody had an equal chance to be chosen. There could be unintended biases creeping in. And finally, replication. Replication means that if we should be able to do the experiment over and over and get similar results. Maybe not the exact same result, but it should be repeatable. If it's a one-off, then it's really not a very useful result. So, for example, 1. Miranda watched her cat for several hours, recorded the activities in which the cat chose to engage. What type of experiment is this? Well, she's just watching her cat. She's not doing something to the cat. So maybe the word experiment is probably a bit misleading because experiment was one of our terms. Let's say what type of study is that would be a better choice of words. And I would say it's not an experiment at all. It's an observational study. And there's no outside influence, right? It's just observing. Another one. Henry threw curling stones on several pads of ice with varying amounts of pebbling and measured how far each stone slid before stopping. What type of study is this? Well, this one I would say is experimental. And the reason why I would say it's experimental is because there is a control going on. There's different levels of pebbling, right? Different varying amounts of pebbling. And so someone is putting different amounts of little bumps on the ice, and so they're playing with that, they're controlling that, and they're just going to then measure the results. All right, when you collect and analyze data, it's called primary source data. Data that's been used but collected or summarized by some other person is called secondary source data. So again, we got another this or that thing going on. So the distinction should be pretty clear in this case. Did you collect it? Then it's primary source. If you got it somewhere else, then it's secondary source. And it doesn't matter where you got it from. Another way that we can describe data is we can talk about microdata, which are individual responses in a survey. So each response is a piece of microdata. But data that's been combined or summarized in some way, such that the individual microdata can no longer be determined, is called aggregate data. So we just have the overall results. Everything's sort of lumped together. For example, the table shows the average domestic airfares for 10 Canadian cities from Statistics Canada. Does the table show microdata or aggregate data? How do you know? Well, I guess the key word for me here is average. It's the average domestic airfares. We're not seeing any specific one airfare in here. We're seeing the average. So it's been grouped together and it's aggregate data. Is this table a primary or secondary source? Well, it's secondary. Assuming we're taking it from our point of view, the fact that it came from Statistics Canada means that I didn't collect it myself. Therefore, it's secondary to me. Identify the independent and dependent variables. Okay, so this goes back to something we've talked about before. So what are we really comparing here? What's the relationship? Well, the relationship is airfare to what city you're based in or what you're flying from. So what the airfare charged is depends on what city you're coming out of. So the independent variable is the city, and the dependent variable, the thing that depends upon it, the thing that's going to change, is the airfare. So conducting a survey, that's another way to collect primary data. So surveys, we could do studies where there's experimental medical studies, things like that, where people actually do experiments or give people drugs or do various other things where they control things. But another way just to get data is just simply to ask people questions, right? So, and we can do that. It could be primary, but it could also be secondary. But the thing about surveys is that they are less controlled than experiments. They're kind of observational, really, when you think about it. But a well-written survey can provide useful information. The following questions, it says, well, it's actually just one question. The following question is biased and therefore will not give representative information. Let's see what we can do about that. So in this example, customers at a car dealership were sent a survey after a sale, and one question read, did our highly trained professional salespeople satisfy all of your concerns? What bias is present in this question? rewrite the question without bias? Well, the bias is when they talk about highly trained professional salespeople. If you really wanted to get to find out if a customer's concerns were satisfied and if they were truly happy, you wouldn't try to lead them on with these highly charged words, highly trained professional. So how would we rewrite the question? Well, rather than rewriting the whole thing out, I would simply just remove those words. Did our salespeople satisfy all your concerns? See, there's no bias in that one. It's just a straightforward question. Yes, no, and then you could ask why, how they did this. Finally, let's look at some types of bias. So certain types of bias make it difficult to get a representative sample or truthful responses. So again, now we're talking about surveys, really. A bias occurs when there's a prejudice for or against an idea or response. So here are some specific types of bias. It doesn't cover everything, but it sort of gives us an idea of different types of bias that are possible. So the first one we'll look at, response bias. When respondents change their answers to influence the results, to avoid embarrassment, or to give answers they think the questioner wants. So really there's sort of three things going on here. There's, they might change their answer to purposely influence the results of something. They might give a false answer because they're embarrassed to say what they really think. Or sometimes they just, if they're people pleasers, might want to just give the answers that they think the questioner wants them to give. For example, a teacher asks students to raise their hand if they cheated on a recent test. Students will not want to admit to cheating on a test, so it's unlikely many students would raise their hand. Well, that's kind of a obvious thing. But I would say as far as those three numbers that I just placed in the middle column, that would be number 2, where they want to avoid embarrassment. Some other examples of response bias might be, maybe I stand on the street in my Toronto Maple Leafs hockey jersey and stop passers-by and ask them what their favorite hockey team is. Well, that would be probably number 3, in that middle column. Give answers. People might be more likely to say it's the Toronto Maple Leafs because it'd be obvious, or fairly obvious, that if I'm wearing a Maple Leafs jersey, then that's where my heart is. And so I'm definitely, even just by what I'm wearing, biasing them. Another thing, the last one, people changing their response to influence the results. You could think of even elections, something along these ways. Maybe someone is a big supporter of the NDP party, but they don't think that the NDP candidate is likely to get into government from their riding, so they might vote for a different party just to keep a certain party out. So they're trying to influence results, but it isn't necessarily what they really want. So again, response bias can take on all those different flavors. Sampling bias is when a sample does not closely represent the population. In other words, it's a poor sample. Here's an example. A politician goes back to a farming community she grew up in to ask for opinions on her latest initiative for the agricultural industry. It is likely that a larger proportion of people will be in favor because she grew up there and it would benefit them. So there's two different things. So she grew up in this farming community, also her initiative, she's asking people who are going to benefit from the initiative. If you really wanted to find out how people felt about a particular initiative, you shouldn't just ask the farmers in this case. So again, everybody should have a chance. Measurement bias. When the collection method is such that the characteristics are consistently over or under represented. Now this could come from a poor question or a poor survey or just the poor tools being used to collect information. A survey question asks, a lot of people do not like math. How would you feel being referred to as a math geek? This is a leading question. It'll affect the outcome of the survey by influencing someone's response. Other types of measurement bias can occur when a collection method affects the results. For example, when the options in a multiple choice question are too limited for an honest response. An example for that might be, who do you think is the greatest Blue Jays player of all time? Vladimir Guerrero Jr., Bo Bichette, Jose Bautista. And those are my only options. Well, those are three fairly recent Blue Jays, and you don't have to be a baseball fan to get this. These are, I'm just telling you, these are some recent Blue Jays players, and there's all kinds of Blue Jays players over the history of the team. By only giving certain options, then I'm limiting the responses. So that would be another example of measurement bias. And the last one I want to look at is non-response bias. And that's when the opinions of respondents differ in meaningful ways from those of non-respondents. So people are omitted. It may be by choice. Some people just may choose not to respond, but only some people are responding for whatever reason, and therefore the results you do gather are going to be biased. This happens a lot with voluntary surveys. A mail-in survey asked respondents about their drinking habits. Only 3% of the surveys were returned. Such a small return rate would not likely yield a representative sample. It's only 3 out of every 100 people. In fact, those who respond often have a very strong opinion about the subject matter. And so the results could easily over or underestimate the feelings of the population. So it's this idea of a very strong opinion for the people who do respond. Another example, let's say the phone rings and someone is doing an on the phone survey. So they call up houses and they want to get some answers to survey questions. If you think about it, most people just automatically hang up on telephone surveyors. What's different about the people who don't hang up? Well, maybe they already have an interest in whatever the topic is. Maybe they're just lonely and they want someone to talk to. Maybe there's something else about their personality. Maybe they're just super polite people who would never hang up on someone. But that's different from all the people who would hang up. And so again, maybe their opinions on whatever the topic is would be different as well. Last example, a government press release says the gross national product for 2013 increased by 1% since 2012. This is due to the new economic plan introduced by the government. What misuse of statistics does the press release demonstrate? Well, in this case, I would say that they're assuming a cause and effect. Just because the gross national product increased by 1%, it does not mean that it was because of the economic plan by the government. It could just be a good time. Maybe all economies are increasing. So assuming cause and effect would be another effect of bias.